So continuing here in 6.3, we've been using to find exact values for trig and reference angles and unit circles and things of that nature. And we were on this problem to find the exact value for 5 pi over 6. So 5 pi over 6 we know is going to end up in this quadrant. And I told you it's easy to find reference angles in terms of radians because whatever the base is what it's going to be. So the reference angle will be pi over 6. So that's going to be reference angle. So your pi over 6 finger, your pi over 6, that's your 30-degree finger, that's your ring finger. So your ring finger is what's going down. So you put your ring finger down. So the ring finger defined sine, square root of the left, which is 1 over 2, so it's 1/2. Cosine is the square root of right, which is root 3 over 2. And tangent is a square root of the left, which is 1 over the square root of the right, which is 3. So it's 1 over root 3 or root 3 over 3. Now you might be wondering, why did I make this one negative? Why did I make this one negative? Because that's why I said, remember the unit circle thing. All students take calculus, apple, soda, toga, cow. In quadrant 2, S, or sine, is positive. So the only thing positive in quadrant 2 is sine and cosecant. They're positive. Everything else is negative. That's why cosine is negative and tangent is negative. Okay? The next one, 315 degrees. That means it's in this quadrant, quad 4. So 360 minus 315 is 45 degrees. That's your middle finger. So your middle finger is what you're putting down. Sine is square root of the left over 2, so that's root 2 over 2. Cosine is square root of the right over 2, which is root 2 over 2. Tangent is square root of the left divided by the square root of the right, which is root 2 over root 2, which is 1. However, sine is negative and tangent is negative. Why? Once again, because of the unit circle. Apple, soda, toga, cow. All students take calculus C, meaning cosine and cosecant. Or sorry, cosine and secant. They are positive. Everything else is negative. Sine's negative, tangent's negative. Everything else is negative. Example 4, find the quadrant containing theta if cosine is greater than 0 and sine is less than 0. Okay, so basically here's what it's saying. Where's cosine positive and sine negative? The only spot where cosine is positive, look at your unit circle paper, the only sign where cosine is positive and sine is negative is in quad 4. Right? Cosine is positive in the first one because all of them are. And it's not positive anywhere else except for number 4. Number 4, it's positive there as well. So the only place where cosine is positive and sine is negative is in quad 4. Some more formulas to remember. The length of a circular arc. We went over this in 6.1. Remember, this needs to be, this is the radius, and this needs to be in radians. So you might just switch that to radians. That will give you the length. That's the radius, and that is the angle in radians. The area of a circular arc is 1/2 r squared theta, 1/2 times the radius squared times the angle in radians. So, taking a look here, if the radius is 4, right, and we know that the length is 10, and I want to find theta to do that, here's what you do. So, put a 10 in there, put a 4 in there, divide them by 4, and I find out that theta is about 2.5 radians. Find the area. Now that I know what theta is, I know the radius is 4, so I plug a 4 in there, and I know that that's 2.5. So I just plug in what I know, 1/2 times 4 squared times 2.5, and I end up getting 20 centimeters squared. Suppose the machine contains a wheel, and that diameter is 3 feet, and it rotates at 1600 revolutions per minute. Find the angular speed. So one revolution around is one time around, and it says that that distance is going to be 2 pi because the distance is 2 pi the whole way around, or 360 degrees. So I know I need to make 1600 revolutions become radians per minute. So to change 1600 revolutions into radians, I multiply it by 2 pi. So I know that there are 3200 pi revolutions per minute. So to find the linear speed, it's like saying find the circumference. That's the distance traveled. So find the length. If the diameter is 3, the radius is actually half of that. So it's 3 over 2 times 3200 pi. So you actually end up with 4800 pi is the distance that the machine's wheel traveled.
I've got the joy.
Here's the homework. Take a look at the example section in this in 6.3. Highly recommend it. I have a lot of examples to show you how to do these, which will make it much, much, much better when you see all the examples. So please, please trust me on this. You really want to look at these examples just to see some practice with them. If you have any other questions or concerns, please let me know.